Hi, I'm Ms. Boom. Let's have a look at application types of questions in circular functions. Now, the relationship between two variables in science and nature often exhibits periodic behaviors, such as sound waves, ovulation, radio waves, tides, musical tones, electrical currents. Today we're going to look at an example. The E. coli concentration in parts per million at a particular beach over a 12-hour period, T hours, after 6 a.m. is described by the following function. So E. coli is a type of bacterium, and P is the concentrations in parts per million, and T is the time in hours. And here we have an equation to describe that. Let's try to visualize this. So P and T are our Y and X axis. Now it's been translated up by 0.1. So the center of your sine curve is going to start up here instead. And we have an amplitude of 0.05. So the highest value would be 0.1 plus that, and the lowest value will be 0.1 minus that, because it's going to do this, right, from the middle. And now we have the highest point to be 0.15, because 0.1 plus 0.5 is 0.15, and 0.1 minus 0.05 is 0.05, so the lowest point will be there. Now what about the period? Well, the period of sine is 2 pi minus the value in front of x, or in this case pi on 12. So 2 pi over pi on 12, well, the pi cancel, so 2 over 12 is like saying 2 times 12, so the period is 24. And so we can put in the other values. Halfway is 12, halfway of that is 6, so we're counting by 6. 6, 12, 18, 24. So notice how I usually put my x coordinates. I write the period, and I go halfway, halfway again, and I know I have to count by that fraction. So 6, 12, 18, 24. And if I land there on the right number, I know that I haven't made a silly mistake. So note that 0 in our story is 6 a.m. So that's a bit confusing. So I've made it red, but if you had this question, you would write it on the side note, or you underline it so that you know that after you have obtained your x value, you also have to consider what does it mean. So if your x value is 1, it would mean 7 a.m. because you'd add 1 to 6 a.m. Okay, let's do some questions now that we understand and have visualized what it looks like. Find the maximum E. coli levels at this beach. We could use the graph, but what happens if you don't have, or you haven't sketched a graph, because that's the first part of the test question? Well, we know that the amplitude of sine is 1. So the biggest value normally of sine, that section there, would be 1. So then we would plug 1 in, so the maximum would be 0.05 times 1 plus 0.1, which is 0.15. So the maximum E. coli level is 0.15 parts per million. And that makes sense. Remember, the middle value has been translated up by 0.1, and the amplitude is 0.05, so the max value is adding those two together. Likewise, we can find the minimum value by plugging in -1, or we can reason it by saying it's been translated up by 0.1, so 0.1 minus the amplitude, which is 0.05, would also give me 0.05. So the minimum E. coli level is 0.05 parts per million. It doesn't matter which way you do it. Part C, what is the level at 3 p.m.? Now what does 3 p.m. mean? Well, it starts at 6 a.m. So 3 p.m. actually means at T equals 9. Double check. So from 6 a.m. to 3 p.m. 7, 8, 9, 10, 11, 12, 1, 2, 3. So it's actually T equals 9. So now we plug in T equals 9 into our equation. So we have 9 over 12, or in other words, 3/4 pi for sine, and we know that sine is equal to 3/4 in the second quadrant, or station, and sine is positive in the second quadrant. So that's the same as sine pi on 4, which is 1 over root 2. And if you plug that into the calculator, you would get 0.135. So the E. coli level at 3 p.m. is 0.135 parts per million. Part D, how long is the level above 0.125 parts per million during the first 12 hours after 6 a.m.? So here we have the graph again. So 0.125 is here. So how long does it stay above that? So we need to find this intercept and that intercept, and we need to find the time frame. So that take away that. Now I've done the scaling pretty clear. So you can see that that's going by 2. So that's 10 minus 2. But how would you work it out? So P equals 0.125, sorry. That's your Y value. So we can sub it in and find when T equals that. So we're looking for these two values. So when we sub it in, subtract the 0.1, we get 0.025 equals that. Dividing by 0.05, we get 0.5. And we know that sine is equal to 0.5 at pi and 6. So that is equal to pi and 6. And therefore, we also have to consider when is sine equals to 0.5 and it's positive, all station to core field, so first and second quadrant. So we have to also include pi minus pi and 6, which is 5 pi and 6. And now all of that is equal to that. So notice that in my working out, I get a little bit lazy. Instead of writing sine theta and then resubstituting it back, I'm just writing it and leaving it there as a chunk, but I don't do anything until I'm ready, which is now. So now, how do I solve for t? Now that I've got my solutions, I can solve for t. So get rid of pi, so cancel out the common factors pi, and then we have 12 left. So how do I get rid of 12? Multiply 12 on the other side, we have 2. So 12 over 6 is 2, and 12 times 5 over 6 is 10. 12 times 5 is 60, 60 over 6 is 10. So P is greater than 0.125 between 2 and 10. So that's 2 and that's 10. Remember, we saw it from the graph, so we know we're correct. So between 2 and 10, and the amount of time between 2 and 10 will be 10 minus 2, which is 8 hours. So the E. coli level is about 0.125 parts per million for 8 hours. Thank you for watching, and I'll see you next time. Bye.